is Prashant Gupta. He's a PhD student working with me and with Jill Dobby in the Centre for E-Research and Computer Science. We're sort of in both places and working on some e-science problem. I'll leave it to Prashant to explain what he's working on to you. But I just want to thank you for being here and supporting him. Of course, you can ask questions. You can interrupt if you wish, if you absolutely must. Ask a burning question. There'll be an opportunity for questions at the end. We're hoping that Prashant will keep his presentation down to 30 minutes.
Okay.
So over to you, Prashant.
Okay, thanks, Mark. So I'm Prashant, and I'll be giving my departmental seminar today. And my topic of research is a step towards capturing the flux in scientific knowledge.
Prashant, full volume.
Okay. Yeah, sure. To start with, I just want to give you a general idea of about the current phase of research. Today, in every domain of science, we require computational aids to deal with the complexity of problems and several dimensions that it's hard for human minds to conceptualize. If we look at the way we do research today, it has been changed a lot in last decade. Today we are swamped with data coming from all over the places, from our mobile phones, from sensors, from social networks, and so on. We can capture and process data as we could never do it before. Similarly, if we look at the process of science, the research process, today we can investigate processes which were hard to imagine. For example, geological processes such as earthquake. We can model such processes and simulate them on computers. We don't even need instruments for those sort of research, and that's what e-research is all about. It's an approach towards better, faster, and doing different way of research using these complex tools and techniques. It is a fundamental step change in the research process, and I personally believe that almost any research in computer science somehow fall within the category of e-research, or at least somewhere connected to it. As far as my research goes, I'm focusing on the change in conceptualization and how that affects these tools and techniques, and how do we deal with that. There are a lot of resources such as databases, workflows, and several applications that are actually dependent on this domain conceptualization. And we can't ignore the fact that the change in conceptualization is inevitable, and we have to deal with it. Talking about the change in conceptualization, this idea of change is actually, we can generalize the fact that everything keeps on changing, whether it is our general understanding about the world, or it's the physical world itself, or our scientific theories and laws. Basically, change is the universal law of nature. And as Whitehead said, the flux of things is one ultimate generalization. Similarly, our scientific understanding is no exception to that. And if we look at the history of science, we can see several examples that actually support this idea of flux. This one good example from physical optics. Today we consider light as quantum mechanical entity which share the characteristics of both particle and wave. However, if we go a century back, in early 20th century, it was considered as a transverse wave motion. And if we go further back in 18th century, light was considered as material corpuscles or material particles. So this evolution of, or this transition in conceptual understanding of what light is, that shows how our scientific knowledge evolves over time with new discoveries and ideas. And basically the flux is an important feature, and and an inescapable feature of our scientific knowledge. Just before I go further, I would like to clarify that fluorescent bulb, I didn't mean that they were fluorescent bulb in 18th century. Sorry, I forgot to replace that with a candle. Let's talk about the current techniques that we use to represent our knowledge computationally. I believe that databases or relational databases was sort of a revolution in representing knowledge computationally to start with, and they were quite good at in terms of storing as a storing tool, but they're crude and limiting in terms of expressiveness. Similarly, XML and other markup languages we use to represent our documents which are more human readable. However, the tags provide some sort of meaning, but they're not shared understanding of that content. It's just specific to a person. This sort of representation lacked a specific aspect which we really need now, which is the semantics behind the content we try to represent. And with the idea of semantic web, we move to representation which not only represent our knowledge, but also capture the meaning behind it or the interpretations behind it, so that we can use that knowledge, share that understanding among different communities, and that allowed us to do computational reasoning over that represented knowledge. I didn't mean here that we moved from databases to ontologies and we don't use databases anymore. What I mean to say that our approach has moved towards more richer representation. Today we connect our database schemas to entities in ontology just to provide that meaning to categories and data. And similarly, we connect ontologies with workflows, maps, and other applications, and such representation actually act as a backbone behind these applications. So that's about how we represent knowledge, and I just talked about the conceptual change. Now I'll come straight to the problem that I'm trying to address, which is how our current computational practice address this problem of conceptual change. What happens to the applications or databases that are dependent on that conceptual representation that has been changed? I believe this is quite important. The problem is quite important, especially at this point of time, because as I just mentioned earlier about e-research and advancement in technologies that help the research progress and increased our capabilities in science. So in that way, we are making incremental changes to our scientific knowledge every day, and that sort of leads to new conceptualization very often as it used to be. And so it is important to address this problem of conceptual change. I believe that, coming back to the problem, I believe that this problem has three particular aspects. So I'll be talking about each aspect and what my proposed solution for each aspect is. The first aspect of the problem is, how do ontologies deal with this conceptual change? So I know that they need to be updated and synced with the current conceptualization, but the point is, are they flexible and dynamic enough to accommodate those changes easily? Before I come to that, I would like to give you an example that how conceptual change or a discovery could affect ontologies or a conceptual hierarchy in different ways. This is an example from geological revolution, which was a result of the discovery of continental drift. The two diagrams here shows the part of conceptual hierarchy or ontology of geoscience. And if we look closely, we can see some specific differences. After the discovery, we can see that there were some new concepts that came forward, like mesosphere and all these new concepts. Another important change is the change in the reorganization of the conceptual hierarchy. Earlier, crust was directly a part of Earth, but now it has moved down the hierarchy, and crust is now a part of plates, which in turn is part of lithosphere, and which in turn is part of Earth. Another interesting change is the change in relationship, that earlier continent and seafloor were the part of crust, but now they are kind of crust. And I'm particularly, for my research, I'm particularly interested in changes that actually cause, that are not just addition of new concepts, but rather change conceptual hierarchy in some form, or for example, if two categories merge together, or if a category split into multiple categories, or if there is a change in relationship between categories. Now let's talk about how ontologies deal with these changes and how well they do it. Well, if we look at the current practices, ontology are often static in nature, and they do not support this continuous revision and refinement of categories. And the reason that it's hard that they support this revision is due to the complexity behind the implication of change. An ontology model is quite rich and has complex interlinked structure. Sometimes a simple change may have ripple effects and lead to changes within its neighborhood. So it's hard for an ontology engineer to see all those side effects easily. So, and another part of that problem is dependency, that, as I mentioned earlier, that ontologies are not just standalone structure. They are interlinked, or they are related to several other applications, or maybe to different ontologies, or to data sets, or some other applications. So if we make a change in ontology, there's always some sort of synchronization problem that we have to face. So obviously, such complex interconnected structures are hard to understand by ontology engineers easily, and that's why they do not support changes easily. So I believe to address this problem, we need to abstract some specific principles of this task, and especially which are quite hard for human minds to deal with due to their complexity, and formalize those specific aspects which would help to automate the process of revision, at least partially. This will make our knowledge representation more dynamic in terms of accommodating those changes, or those conceptual changes. Moving on to second aspect of my problem. As I mentioned just now, that how ontology doesn't, how they're linked to other applications and structures. They're not standalone. So there are a lot of resources that use ontologies as their backbone to support computational reasoning or to share common understanding. Now, how these applications deal with conceptual changes? What happens to the applications that were based on previous conceptualization? I'll discuss two specific examples. One is about databases, and one is about maps. The major problem that we often see in databases is the problem of semantic heterogeneity. When there is a change in conceptualization, the underlying interpretation of the concept changes. However, we sometimes leave the name of the concept same. So even though the name remains same, they have different interpretations. So it's hard to combine two schemas which have the same concept name, but the interpretations are different unless we have some sort of link for each database schema to what they mean. So it would be hard to know whether it's a beer drinking man or a beer is drinking man. And similarly, sometimes we just change the name of concept due to a societal need, or we think that that's a better explanation of what we meant. So in that case, the name of the concept changed, even though the interpretation is still the same. So how can we sort out this problem unless we have, in case of conceptual change, unless we have somehow a connection between the schemas and what they mean for each version as our concepts change over time. Geographical maps, they're another important application that use classification schemas and are affected by conceptual changes. How do we deal with the situations when our categorical schema changes, but we need to use the geospatial data that is based on the previous schema? And a good example is Kyoto Protocol, where we have a new legend, but there's no accompanying New Zealand map for that. And similarly, how can we compare two maps based on schemas built on different time? Or how can we integrate them together? These are the sort of problems we might face when we have different versions of schema, or when there is a change in conceptualization, and that affects our categorical schema. This is an example. The three maps here displays the data for Great Barrier Island, and the data is from LCDB2 spatial map, which is land cover database. However, we used a different legend and integrated that with the data from LCDB2. That one is from LCDB1, LCDB2, and that one is from EcoStat. What I'm trying to convey here, that the situations where we need to use our geospatial data from a different schema and then use a different legend and combine them together to provide a virtual map. How can we do that unless we have some proper relationship between the two schemas? So in this case, you can see that the white color actually shows the gap between that exists in the relationship between the schemas. So it's hard to interpret the map unless we have proper connection between those schemas. And to address this issue, I believe we need to have a category versioning system which records different categories as they evolve and have them connected with the corresponding versions of the application that are based on those categories. That way we would be able to save our knowledge and applications that were based on previous conceptualization. And it will also help us to compare and track the evolution of our knowledge. Let's move on to the third aspect, which is how can we capture the flux? And what I mean by flux here is the process of change rather than the change itself. But first we need to know why we need to capture this flux. Today, most of the scientific research, not most, but I would say there are several scientific research that are involved in understanding about things, that how things are the way they are, or what were the processes or factors behind those changes or behind that evolution of things. So for example, we study about the evolution of biological species. We study about geological processes. A good example is the study about evolution of languages. We try to understand how language has actually evolved, why the language is the way it is, why we use certain word, and why it's been pronounced the same way. So all these research in different domains are trying to understand the process of change and the reasons about why that and how that change happened. Then why are we not capturing the process of conceptual change? And maybe we might do it like few years or 100 years later, depending on the domain. But I believe this is important and it needs to be captured. What are we exactly missing behind this process? If you think that different researchers come up with different understanding and different interpretations of same data and may form different categories. Especially in geoscience, field scientists form categories on the fly, and it totally is reflect their background knowledge and their intuition, their situational knowledge and social factors and so many other things. So the understanding or the interpretation behind a knowledge structure actually depends on the process that it goes through. So the knowledge is hidden behind that process, which we normally ignore. So we lack a model that could capture the process at the same time the knowledge is generated. So what we need is an approach to represent our scientific knowledge that not just represent what is known, but also tells us why that knowledge is the way it is and tells us how that knowledge evolved over time. So in this case, my proposed solution is to connect those categories which are symbol of our worldly knowledge, which we represent in terms of categories, and connect them with the process of science that drives their formation and revision. I believe this will help us to understand the deeper meaning associated with our knowledge and help us to track and understand the evolution of our conceptual understanding. That's more about the problem and my proposed solution for each aspect. Let's talk about a bit of specific details about my research. I'm proposing to use categories as one of the static knowledge representation structure and explore how flux in scientific knowledge actually affects categories and how can we deal with that conceptual change. So categories are basically the instantiation of our concepts and can be considered at the smallest unit of computationally represented knowledge. I'm trying to use categories so that we can make it simple and explore it properly. Let's see how we actually represent a category in our computational system. We normally use three facets to represent a category, which is intension, extension, and place in conceptual hierarchy. Intension is either a rule or set of attributes or features in a schema. Extension are the entities that belong to a category based on the rule that is described in intention or adherence to the schema. And the third one is the place in conceptual hierarchy. In general, we normally use intention and extension. The reason I also used place in conceptual hierarchy was because we are dealing with conceptual changes. And it often happens that sometimes the categories intention and extension doesn't change, but its place within the conceptual hierarchy moves around. So these three facets actually represent a category's identity in our contemporary system. But I argue that they are not enough to explain the existence of a category or the complete meaning associated with the category. I'll explain that with the birth and evolution of category. Start with the birth of category. There's several factors that are involved when a category is formed. Contextual factors, situational, researcher's knowledge, his intuition, decisions researcher make based on his previous experience, then the processes that categories goes through while during its formation, the data and the underlying theory. But once category is formed, we normally lost all those connections, and in a way, we kind of lose the part of an identity of category. It is important in our current systems. We just represent a category with intension, extension, and its place in conceptual hierarchy, but none of them actually completely describes how category came into being, means without those factors. So it's important that we capture these factors and represent them with the category representation in computers. Similarly, if we look at the evolution of category, means category goes through several changes during its life, and there could be several factors that could lead changes to category, such as a conceptual change, new observation, or richer characterization in terms of new attributes or new relationships. But again, we kind of ignore all these factors. The only thing we record is the changed category in terms of its intention, extension, its place in conceptual hierarchy. I understand that it's not possible to capture each and every factor, especially computationally, because several factors are hard to capture. For example, researchers' head knowledge or his intuition, the decisions he makes based on his previous experience, you can't capture that. But I believe there are still several aspects of the process of the whole change that we can capture, and that would give a more deeper understanding about what category is and how it came to, would define better why the category is what it is. Okay, I'll move to my research goal, and as my problem indicated earlier, the three aspects of the problem. Similarly, I have three aspects of my goal. First one is to make our knowledge representation more dynamic. And we can make them dynamic by formalizing some aspect of the process of change and try and automate the process, at least partially, as much as we can. Just want to clear that I mentioned here the category revision process. However, category doesn't exist individually. They are always embedded within some conceptual hierarchy. So it often happens that a change to a category may lead to change within its neighborhood and change to other categories. So I'll be dealing, so my research will also deal with situations where I need to consider multiple categories or the whole taxonomy as a whole. Second aspect is to make these categories more living and more meaningful by connecting them to the processes that were involved in the revision. And I believe this explicit connection of categories with the processes that were involved in the change would tell us the path that categories has gone through during its life, and through that we can track how categories and our own knowledge about that evolved over time. And the third aspect is to not to lose our previous knowledge if there is a conceptual change. So I propose to create a category versioning system which records different categories and have explicit connections of those categories with the corresponding applications that are based on them. move to achieve these goals. I have some concrete research objectives, which I'll tell now. Okay, the first objective is to start with building a conceptual model that would explore all the factors that may cause changes to category. And corresponding to what conceptual change, what sort of effect would it have on the category? Could it be merging two categories, or splitting, or deleting, or modifying a category? So I believe through this I can actually capture the inputs and outputs relating to different kind of changes, and this will help me to capture those aspects and formalize them and help them to automate that process of revision. Next objective is to build a framework. Here I have shown a framework in terms of the input I expect and the output I expect from my framework. So the framework will be flexible enough to allow researchers to input change events. So what I mean by change events are the factors that may lead changes to a category. So it could be a conceptual change, new instance, anything that could lead changes to category. And other information that might be required during the process. And what I expect from the framework is a revised categories, accommodating those changes, and a category versioning system, and also a richer representation of category, so connecting the processes and the factors that were involved in the revision of that category. So for each aspect, so in case of revision of categories, as I mentioned earlier, I need to formalize the change events and the effects so that that process could be partially automated. And especially, for category versioning system, I would capture the provenance that categories goes through. And also, I didn't show that, but I would connect those categories, or would have some sort of pointer from applications to those categories, depending what applications are based on what version of categories. So that sort of output I expect from the framework, and yeah. And finally, it comes to evaluation. So I'll evaluate my framework in terms of its correctness by using some data sets and categories that has already gone through some conceptual change, and reproducing that conceptual change so that I can say that, yeah, that it's working as per what I wanted. And then evaluate the benefits of the framework, that maybe connecting two data sets or querying two data sets which are based on different categories version. Okay, yep, that's it. And thanks to Mark, Jill, and Pat, and my fellow students. And any questions? Yep.
I know, in attacking a complex problem, you decompose it into parts and focus on something that seems tractable.
Yep.
But one part that really seems missing from this is that the reason why you have categories is because they play roles within models. So you have a model of geological change. And in order to talk about the model, you have components in the models, and those are sort of the category, instances of various categories. What drives changes to categories is discrepancies between models and their applications. Someone is trying to explain, why did we find these fossils over here and over there, and they're separated by thousands of miles of ocean. Okay, so given this model of how the world evolves, how the geological formations change over time, they can't match the application explaining why fossils similar fossils are so geologically dispersed. And so they start changing that concept. But the concepts are really subsidiary to the models. It's trying, and I'm not saying that you need to attack models, but I think if you're trying to capture why do categories change, you have to think about what role those categories play within models and what roles those models play within the applications in the real world. Without that intermediate, the role of the model, I think you're going to be lacking
Right.
a very important part of the picture.
Okay.
Why do they change? They change because the model changed, and the model changed because of these lack of explanatory or predictive capability.
Right. Thanks. Yes?
Okay, so this is after your first year of PhD, right?
That's right.
You do a literature survey, and you haven't presented much of literature that you have looked at.
Yes. Yes, I haven't, but I know that some aspects of the problem which I described here have some work done, but like when I talk about the category revision process, there have been some work done in terms of taxonomy revision. There's a specific application retax, but what they have focused on a very simple addition process rather than reorganization of hierarchy. So the aspects I have explained here, I think, are not yet been addressed.
Okay, but we would have to see the related work. It's very important that we based on related work, we say what is the difference, what are you addressing?
Right.
Are you planning on just having like a single ontology? I mean, lots of times different people want to look at a single problem in two different ways. So you might have like regular physics where you're like rolling a ball down an inclined plane and you want to talk about center of mass or whatever, as opposed to, like talking about the electrons, like your computer isn't sitting on that table, the electrons in your computer are pushing against the electrons. Sometimes you don't want to look at it in that much depth. You want to look at it at a higher depth. Are you going to have multiple, multiple ontologies or multiple views of your ontology so that for this particular application, we need to look at this level, and for this particular application, we need to look at this other level?
Right. Well, I think it doesn't depend. It doesn't really matter if what ontology we are using, or we are using. It's not dependent on a specific ontology, right? So my focus is on a level of abstraction, not looking at the whole taxonomy as a whole, but looking at categories. So I'll have a so whatever taxonomy, is it from the biology or from physics, doesn't matter. I'll be looking more at an abstract level of categories rather than the whole taxonomy, and how categories evolve, how they how applications are dependent on them, and how can we save that use that knowledge which is based on previous conceptualization, even if the conceptual changes happen, by connecting those different versions of categories. So, did that answer your question?
Not really, but that's all right.
Yes.
So you pointed out that categories exist within taxonomy, and you also talked about semantics. Now, does this mean that you associate logical expressions, some sort of formulation of what the semantics of a category are?
Yeah,
and if so, how?
Okay. In terms of implementation, yeah, I definitely think that I would be dealing with semantics, because I would be representing those categories semantically in it, so that they can be further reused. Or if I'm making a category versioning system and connecting them with other applications, I need to make them formalized, right? So, but what sort of techniques, whether it's a logical first order logic or whatever I'm going to use, I haven't really looked at that part. Yes.
So you mentioned databases as one major field of applications. The databases schema evolution has been studied for 15 years, at least.
Right.
And so I would be wondering, what's the unique contribution of your proposed research that distinguishes it from that research. The same applies to AI. I mean, ontologies have existed for many years. The AI community is much larger than the database community. So I'd be very, very surprised if they haven't studied ontology evolution.
Like I mentioned earlier, they have, and there are some specific aspects which have been, if we look at the structural changes, they have dealt with it. If we look at simple addition of new instances, they have formalized those changes. But when it comes to more complex changes in conceptual hierarchy, there are no such systems that that have addressed that problem in a sense that it could be more formal or automated.
I would do a very thorough literature review on that.
Yes.
Have you looked at psych?
Psych, yeah.
Yeah, because I mean, psych, I would think, of the more well-known systems would be one where they would be concerned with this type of thing. So I too would be surprised if they hadn't, had to address some version of this problem.
Right.
Can you go back to the evaluation slide?
Sorry, which slide?
The next slide.
Evaluation.
Evaluation. Okay.
So, you mentioned that you want to look at available conditions. And you said you want to look whether your framework can reproduce them. I think it's not clear what actually the evaluation is. So what kind of measures are you putting?
So I want to evaluate two specific aspects of my framework in terms of correctness, whether it does what it's supposed to be. So if we use categories that has already been gone through some conceptual change, and if we try and use that and see if it produces the same sort of changes in our framework.
But I mean, so first of all, so I guess the changes are of course produced by users, so you can't really produce the changes, and then you really have to, before you do the evaluation, you have to fix the measurements. Otherwise, I mean, it can't be that you evaluate. Yeah, so it doesn't work that way. That you just look at this, it looks good. So there has to be some objectivity in it, and there has to be at least something that another criterion is falsifiability.
Right.
And so it also must be able to fail, and I don't see that at all. It's basically just writing it up in something and then saying looks good. That's so it's not a. So I think we really have to be very clear about how you are critically evaluating.
Sure.
So I think it might also help to look into recent research on provenance.
Right.
Since this is what you're essentially proposing. You're looking for provenance model for change.
That's right.
Something like this might exist.
Okay. Yeah, definitely. I'll have a look. Sure.
Any more questions? Okay, well, thank you, Krishan.
Thank you.
Okay, so there's going to be bagels and coffee and such down in the 4th floor shared common room. So if you have any further questions, that might be a good place